we got down to a list of about 600 microbes that are common in people. Over 20% of people have them. And we got that into a short list of 100, found that there were 50 good ones and 50 bad ones. And this list of this 100 translated really well into other populations around the world. And consistently, the ratio of the good bugs to the bad bugs, the more good bugs you had and the least bad bugs, the better you were, and vice versa.
Today, I have the great pleasure and honor to speak again to Dr. Tim Spector, an internationally renowned authority in the field of microbiome science and personalized nutrition. Our conversation is focused on the recently published landmark study published in Nature about the associations between gut microbiome health and disease. Dr. Spector is a professor of genetic epidemiology at King's College London, honorary consultant physician at Guy's and St. Thomas National Health System Foundation Trust, and the scientific co-founder of the company Zoe. Throughout his career, Dr. Spector has received many awards and prizes, and is a fellow of the Royal Society of Biology and the Academy of Medical Sciences. He has published over 900 scientific papers and is ranked by Google as being in the top 100 most cited scientists in the world. In addition to his scientific publications, he has published 4 popular books, including the best-selling Diet Myth, Spoon-Fed, and more recently, Food for Life, a Sunday Times bestseller. Welcome to the show, Tim. Pleasure to have you on my podcast again. It's not been too long since we last talked, but I think there's a particular reason why we're having this conversation today again.
Yeah, exactly. I don't get papers in Nature every day, so that's why it's very exciting. Yeah, in my career, it's fun to talk. Scientists don't get enough chance to celebrate things, so it's good.
Yeah, and this publication obviously has a lot of implications, not just for scientists, but I think in the near future for consumers as well, and for people interested in healthy diets and how they can assess their own gut health, microbial health status, and what they should do. I mean, some of the findings in that study are confirmatory of things we knew about, but in a lot more granularity and reliability than it's ever been shown before. So I think it's really exciting to talk about this. Yeah, let's talk about the study design in general. What was unique about this study, and how was it possible to put this together? I mean, there's few other entities in the world, probably none that I know of, that could put a paper like this together.
Yeah, well, I would have found it very difficult to do this academically. Obviously, most of my life I've been in academia and struggle to get grants to give you sufficient numbers to do the sort of things that we're doing. So just so people understand, what we're talking about here is a core set of 34,000 people with full gut microbiome metagenomes, which is the most detailed way of looking at the gut microbiome, who also have full dietary data in great detail, and also have health data in great detail that has never been done before. So that's never been assembled before. And that was only really possible because this was under the auspices of Zoe Limited, a nutrition science company that has basically been selling predictive nutrition by giving people gut tests. And at the same time, they sign a consent form to say they're happy to give their data for research. And so in a way, it would have cost millions and millions to do this academically, but each individual is just paying for it. They contribute, and we've got a nice model where, in a way, they're acting as citizen scientists. And so this allows us to get to the sort of size we need to start making discoveries, which up to now we've made lots of mistakes because just not through incompetence, but just the complexity of the gut microbiome and the fact that we, unlike our genes, which still take similar numbers of people, but unlike our genes, all our gut microbes are different. So you and I would only share 20% of our species. So it's very hard to say, how are you healthy? What's your healthy gut look like compared to my healthy gut? So that's why we needed these really big numbers to
If I may
crack
interrupt
it.
for a second. So, I mean, this is a question that has always come up. What is a healthy gut microbiome? And that question is actually a wrong question, because it's not just one healthy gut microbiome. But I think the study shed light on that question. So I think if somebody asked me, today, I could probably give a more confident answer to that question than I have been in the past.
Yeah, well, that's exactly right. And that's what we're trying to do, is because, since I started in this field in about 2009, we've only had one measure of a healthy gut, which is how many different species do you have in your gut? This diversity. And, it worked pretty well because we couldn't find anything better, right? It was a way that took into account the fact that we all have very different types of microbes in different ages and disease states and parts of the world, as well as just individually. But this is the next stage. It's superseding that, because what we're doing is we're saying, well, okay, let's just look at the common microbes that we do have in common. Let's forget the really rare ones that we can't make sense of. And that's essentially what we did. We got down to a list of about 600 microbes that are common in people. Over 20% of people have them. And we got that into a short list of 100, and found that there were 50 good ones and 50 bad ones. These were ones, and this list of this 100 translated really well into other populations around the world, and consistently the ratio of the good bugs to the bad bugs, the more good bugs you had and the least bad bugs, the better you were, and vice versa. That was really robust across people with different diseases, people with high cholesterol, people with obesity, diabetes, and about 30 studies of obesity, which included people in other continents and on other diets. So that's why we saw it was consistent.
So you were saying initially these were 34,000 people that you had the Zoe test information on,
Yes.
from different cohorts. So this wasn't just
there were different cohorts because they were taken at different points in time over the last 5 years, and some of them were from the US, some are from the UK, some were sampled slightly differently. So we treated them as different cohorts and then merged them together in this process of meta-analysis. But they all essentially had the same health data and the same diet data. So that was consistent. So that was our core. But then once we'd got that, we then compared it to about another 20,000 little samples from around the world that were on public databases that we could look at to see if it really worked in lots of different situations. So it wasn't just a one-off just for Zoe customers. It was actually something that clinicians could use around the world if they wanted to, in different states.
Yeah, sorry to interrupt, but one question about this. I mean, the challenge when you go to other databases, there has been an evolution of the way that the microbial community has been measured and assessed from the simplest one, that's the 16S sequencing, to shotgun metagenomics and metabolomics. So you were able to, all these other studies that you validated your Zoe findings on, that they had comparable ways what the microbes were measured at the species level or even at the strain level?
Well, we reanalyzed them. So we couldn't work with the 16S data, which, for those people listening, that was how the whole thing started. It was a fairly crude measure where you just look at one gene in each microbe, and you guess based on the different variants of that gene what the species is. And it was a good thing. 20 years ago, it was really amazing, but now we know that you miss most of the information by it. So we didn't use those. We just used people that had done full shotgun sequencing, where you look at all the genes and all the microbes. And then we reanalyzed that with our new computer program, so they were comparable. And then but just focusing on the 100 microbes. So you didn't have to do the whole analysis, which anyone listening that, it's a horrendous computational exercise to do this, and you need very big computers and a lot of time. So we simplified it and just looked at this ratio of the 50 good, 50 bad across another 20 or so cohorts around the world, which had looked at obesity or high cholesterol or diabetes, etc. So we saw that it worked in all of those cases. This ratio really picked out, separated the cases from the controls. So that's essentially how we did it. And I think it's a great model, going forward. And what I think is really interesting is how the microbiome data is mirroring what happened in genetics. So I'm old enough to, done one of the first genome-wide associations studies in the early 2000s. And for the previous 10 years, we've just been doing these small studies on 100 people and produced so many false results that, it got beyond a joke. So we're finding genes for this and that, and then not finding it. And it was a false dawn. And I think a lot of the stuff that's been coming out of the microbiome has been criticized for not being very reliable. For a similar reason, that the databases have been too small, hasn't accounted for individual variation, and some of the techniques have been used, these rather crude ones, that has given the field, I think, a bad name for slightly unreasonably, given that it's still a new field. So I think hopefully this is a new dawn in this area, because once you've got this solid base, then you can build up so much more on it. But we needed something that does work around the world.
So one question I had about this, dividing it up into 50 good ones and 50 bad ones. I mean, the good ones, I think there has been kind of a slowly growing consensus. It's, if you oversimplify it, it's the ones that produce the short chain fatty acids, the butyrate, that have anti-inflammatory and a variety of positive effects on the body. But this has always kind of bothered me that, we're focused onto one substance. I mean, the body doesn't work that way. That it's just the butyrate that makes the difference. The second one is, I mean, I think you can give some answers about the good ones, because you have some very new findings on that one. But what about the bad ones? I mean, how do you define the bad ones? I mean, what do they do to our gut, to the body?
Well, I mean, statistically, we define them as those associated with a bad diet. So people having lots of processed foods, the worst junk food American diet. Those people had high levels of them. So that was one thing. And they also had poor health outcomes. So they had bad glucose levels, cholesterol levels, inflammation levels, body weight, diabetes, heart disease risk, etc. So we knew that was, and in those, the worst offenders, actually, there were a lot of friends that we knew from the literature. So even from the 16S, the early literature, a lot of these bad guys had come out. And most of the ones we knew about were these pro-inflammatory ones. These are ones that microbes that like living in an inflammatory environment, where the immune system is stressed. Maybe there's a change in pH in the gut. There are a few new ones, but many old faces there that we'd picked out from case control studies in the past. There were less surprises on the bad guys, but it was the good guys that were the big shock, because hardly any of them had we guessed at before. And most of the ones that we found, I think at least half of them hadn't even got a name. They only had a number. Not only is, some of the named ones we don't know much about, we've at least given them a name, but these guys didn't have a name. So we have no clue really what they're doing. And I think, going to your point, I agree. We always have a tendency in science to be reductionist and say, aha, it's so easy, it's just butyrate, or it's so easy, it's, affecting GABA or GLP-1 or whatever it is. And of course, that's a reflection of our general ignorance in science. And the fact we just haven't, it's going to take several years to work out what the function of all these guys are, because the microbiome, is very complex. 200 times more genes than in our body. We still don't know how all the genes in our body work, let alone all these microbes. At least now we've got a short list that we can focus on. And if we can start to understand what they do, then we can either, these could be potential therapeutics. We could be designing more prebiotics or probiotics that help them. It can be advances, but I agree, like you. I don't think we should make assumptions about their function, trying to fit them into some model that we've got. We just, need to come at them with an open mind. I suspect quite a few of them will be affecting our immune system, and which seems to be increasingly the big driver here of how good bugs work.
I almost think that this is the most amazing finding from your study, because it opens up a whole range of research, also in terms of what kind of interventions. Does a general prebiotic, or there's thousands of fiber molecules. It's quite possible that they don't respond to the same fiber molecules, or many of them have sort of the unique preference for which fibers they utilize to produce whatever their beneficial effect is.
Once you can separate them out, you should be able to learn a lot. But I think, just stepping back a bit, what was really interesting is with this new scoring system, it really helps when you're doing intervention trials. So we did this trial comparing a standard probiotic. It was Lactobacillus reuteri against a control breadcrumbs and against our prebiotic fiber mix called Daily 30, which has these 34 freeze-dried plants in it. And when we used the standard testing method, the diversity, there was hardly any difference between them, which is really interesting. So, there was a little difference, but it wasn't significant between all three arms. And that's probably because it might have been, increasing the number of good bugs, but reducing the number of bad bugs. So the diversity didn't change, right? It sort of makes sense now, but up to then you say, well, that's failed. So we showed that we did get significant effects of the probiotic and the prebiotic, the Zoe Daily 30, above the control, but actually the effects were much bigger in the prebiotic. They were 10 times bigger than in the probiotic. So we shifted like 57% of that top 100, those microbes either went up or down, influenced by this combination of fibers. Whereas the probiotic didn't.
So this was a combination of the prebiotic with probiotic, or just the prebiotic?
No, just the prebiotic on its own. So this is just, 6 weeks of taking either, 1 to 2 scoops of this prebiotic, which gives you, 5 to 10 grams of fiber, against a regular probiotic, L-reuteri, which, has had 20 studies to show it works. Yeah. So we know it worked. But because people, it's quite interesting. So does a probiotic work more than a prebiotic? And I think the idea that probiotic is a bit individualized, why should one microbe have this massive effect in everybody? And it probably works really well in some people, but not across the board. Whereas if you give 34 plants, probably hundreds of different fibers in those plants, that allows all the different good microbes to actually feed on something and increases them. And so that's why we had this massive shift just with that prebiotic fiber, compared to the rather modest shift of only, I think it improved 4 microbes, whereas we had over 40 improved in the prebiotic. So I think this is going to help us understand some of these differences, which up to now we've only had a real crude understanding of, what's better. You ask, any doctor, should I take a probiotic, should I prebiotic? We don't know, we just say, we'll try them all. But now you can actually put people, on these tests and actually monitor their progress with this gut test. So I think it's really cool.
So would you say, I mean, there has been some improvements, from the early days of the 16S sequencing. There were companies, I still remember patients coming in with this 50-page report from some company that they got and had no clue. Neither had their doctor, so it was a total waste of money in the beginning. But in the meantime, there's new companies that have popped up to do metagenomic sequencing and much more accurate evaluation. I mean, do you have to do the Zoe stool test in order to derive these, these health rankings that we've been talking about, or can you apply the same information that you collected, which is publicly available, I guess, and interpret these test results of other companies?
Well, I mean, in the paper, we obviously released the rankings so people can actually work out their rankings. The companies that are currently using this very crude diversity index can change for this new system. It will take them some time because it's not easy. It took us years to do this. And I think it's quite hard for the members of the public to do that as well, because the fact that they don't have names means that a lot of these companies won't have actually measured it or don't have the latest software to detect them as well. So I think for the moment, the only way to do this would be with the Zoe test, but I think eventually they should all adopt this approach, and so it should become more widespread and easier as it gets more refined. So, but I think we want to move away from the 50-page report. I mean, that our hearts have always sung when we've had patients come in and throw this on the desk and say, okay, you're the expert, sort it out. And most of it is basic mumbo jumbo. They're just making stuff up. We don't have real knowledge that would fill 50 pages that is useful to a patient. So Zoe, we've got it down to basically one page, which is sort of really all that truthfully science can tell you. It's not going to tell you, just because you've got this one bug, everything happens. We know that it's not particularly useful for predicting individual diseases. It's a global snapshot of where you are. We have now got clusters. So we've got an overall score, which you get out of 1,000. So, anything above 500 is good. Which you can compare, and that will change over time. But we did develop these clusters very recently, which allows you to look at. It's not a medical device, so we have to stay clear of calling it. We can't call it diabetes, so we say glucose control. We've got one for lipid control. We've got one for body fat, how quickly you put it on, and we've got one for the immune system. And so these subsets we've just put in place now, so we don't know how they perform long term, but we, rather than an overall score, we've got these 4 subdivisions, which I think will be useful if people have particular problems, say with an autoimmune disease. You'd really want to get the microbes that are important in the immune system. You'd rank those higher than you would, say, for body fat distribution or something. So I think we're going to start over the next few years really improving our ability to tease these apart. Whereas at the moment, it's a snapshot of your gut health, which we know is very good for everything. But within that, I think there's lots of little secrets we can dig out. And it'd be lovely to see effects of treatment, for example, on, like the immune cluster.
Yeah.
As you start people on steroids with colitis, for example, can you see that improving? Or so, it'd be lovely to get this sort of stuff used by clinicians more.
So, we're going to talk about this in terms of these various disease cohorts that, but I was just curious, I mean, how do you see it? Do you see that if you have more of these bad guys in your gut microbiome, that by itself doesn't cause any health or any disease? There's got to be other factors like genetic risk genes or, so
they're setting the environment. It's your inner environment, if you like. So, I mean, I think we've got to accept the most common disease are multifactorial. There's an element of genetics, there's early life, but diet and gut microbiome are a very big part of it, and the reason we're in the mess we are, in the USA and the UK, is our terrible diets. And the fact that we've accumulated these bad microbes, if you go to healthy populations, you just don't see, is a measure of the fact that we've been eating foods that's allowed them to multiply and, send off chemicals and things that is giving the wrong signals to our immune system, which is then making it much more likely we're going to get all these other diseases. So it's not a black and white, this causes disease. It's massively increasing our risks and upsetting the immune system, which is our main defense against disease. So that's the way I see it. And so what's also interesting is when we looked at our longitudinal studies with this new score, we've changed our mind, and it looks like the way to get rid of your bad microbes is to increase your good ones. So you cut rather than the other way around. So it's not like if you cut out the bad ones, you'll get good ones. It seems to be easier to focus on positive action, so that essentially there's no food for them to eat. You create an environment that makes it really hostile for the bad guys to continue living. And I think that's an interesting concept in our advice, so that just don't give them the junk food environment. Keep feeding the fiber. The ones who like the fiber will be the good guys. They're the ones who will then take over your gut, leaving no room and no spare food for these other guys who might like living off processed meats or unhealthy pro-inflammatory foods. So that's our current understanding, but I'm sure we've got a long way to go.
There's always this question about causality several times in the paper that, and I'm sure, any reviewers of manuscripts will insist on that sentence anyway, that, the study.
They did, yes.
Causality. So these are associations that we currently have, and probably this paper shows the best example of such correlations. That and it links health-related data with diet, with microbiome assessment. Like all these variables are associated with each other in a way that you would conclude, there is a causality. There should be a causality between them, but it's what will it take to actually prove that it's that the microbes and whatever they produce, I mean, it's not the microbes themselves, it's what they produce, that is a causative factor in many of these diseases?
Well, it's going to be tricky. So the bar is very high, because obviously we've got our big cross-sectional data. We had a small longitudinal one to show that, because I should say that these 100 top microbes were the ones that changed when you change diet. Okay, so there's no, for our purposes, certainly there was no point in identifying microbes that never change, right? That because they're not amenable to interventions and not practically very useful for us to track people over time. So we ignored those ones that low level don't change. We just picked the ones that do change with diet, and that again was quite novel. But in order to prove what, we'd have to basically create some probiotics from, say, the top 10 microbes, grow them up, cultivate them, make them in big batches, give them to people in a controlled trial, and then report the effects of that clinical trial. That would be your gold standard proof that these things are beneficial for you. Quite hard to do, and you'd have to sort of separate them out. And we still find it very difficult to convert findings like this into therapeutics that can be used in that way. So that's why I think the other approach that we're doing is, we think, I was shocked when that study that the Zoe prebiotic against the probiotic, how big a difference it was. That changed my mind, because up to that point I thought they were at least equal, the effects of probiotics versus prebiotics, because most of the fiber studies pretty much failed. That was again using this old system, so we may want to go back to those studies to say actually they were working. We just thought they weren't very good. But my point is that we might, rather than doing those individual probiotic studies, we might want to just look at prebiotics and see, do these prebiotics increase these microbes, these 50 microbes or whatever? Does that have an effect versus another dummy prebiotic that doesn't change them? And then you put that into a trial. Maybe that's the way, is these specific. That seems a lot quicker to do, because the probiotic route, it's hard to see anything happening within 10 years at the current rate. It's so hard to isolate these and get them to market. With prebiotics, very safe. You can put them into foods, get them straight away. And we just can now measure this. So I think that's what I'd like to do, is see if we can tease apart the good and the bad with interventions like with these fibers.
And there's an interesting, I've sort of talked to several people from food companies. So there's a race on in creating healthy beverages, so away from the sugar-laden, drinks without any fiber. So there's a trend now that I've seen, that companies start adding fiber, either synthetic fibers or natural fibers to drinks. So basically, I'm sure these companies are gonna love this paper, because clearly they would have an easy way of finding if this is beneficial to the microbiome. You do a trial looking at the index that you created, the ratio, these 50 good and 50 bad ones, with simple addition of these drinks 3 times a day, sodas or whatever. It's not difficult to actually consume those fiber products. They don't taste like anything. Do you think that's something? Do you see that coming as well?
Well, yes and no. I'm a bit I'm skeptical that the big food or drink industry ever does trials, unless it's just a marketing-led one, because they can sell stuff just by marketing it. And there's too much risk in doing a trial in case it fails. That's why Zoe is quite exceptional in actually doing this trial, because 99% of our competitors don't. In all the supplement world and all this, it's the most obvious thing that they're not doing. I'd love to see trials being given more weight by consumer groups and associations, and being rewarded for spending the millions that it does take to do a trial properly. They could do it. They have tried adding fiber to things like beer in the past, interestingly. I did speak to a Spanish company that did this, who wants to be nameless. And it turns out they make people fuller, so you drink less of it. So they stopped it. So that's the other thing. If you put too much fiber in, people can't drink enough of it. So you'd have to charge a lot to get it in there. So it's sort of going against the grain of what these food companies want you to do. They want you to over-consume it massively. So that's why I think they might end up just putting placebo amounts in, calling it fiber, marketing it, a bit like these probiotics in those colas, Olipop and things like this. No one really believes they had massive amounts in there, but people saw it as a health alternative, and it made billions. So I'm a bit cynical about the food industry, but I'd love someone to do it. So if anyone is listening and want to do a trial, absolutely, love to help them. But it's a tough world out there, because particularly in the US, marketing is still king rather than science.
No, it's unfortunate. Well, there's a certain sense of optimism right now with, not that I'm endorsing the people behind it, this Make America Healthy Again movement, but it's certain, unfortunately closely linked to industry as well, to industry interests as well. So we'll have to be seen, how successful that actually is. But there's a new kind of environment in the US that will listen more to these
It's certainly better than it was a couple of years ago. And I think, yeah, you're absolutely right. So I think we're right to be a bit cynical, but at the same time, I think we're moving in the right direction, and the public are demanding healthier food and people to help them. Even if big companies are talking about adding fiber to their drinks, even if it's a small amount, that's signaling that fiber is important, and moving away from the protein trend, which is massive. And we all know we're getting twice the amount of protein we probably need, and we're ignoring a lot of other stuff because of this obsession. But so I'd love to see it in more products, and but I think a diversity of fiber is important. So we need to start looking at some of those early trials again, and where they were just using, say, inulin or GOS and FOS, which are the three commonest sort of types of fiber used by industry, to say, well, is that enough to keep all your microbes happy, or do you need a blend of the 100 commonest fibers? So that was the sort of rationale, for us using 30 whole plants, each of which has a whole different set of fibers, because we didn't know which ones to use. So let's just give as many as we can. And I think going forward, to me, that makes more sense, is that we don't want to be reductionist and say, well, there's only one type of fiber that's going to really feed our gut microbe. It's like going to the zoo and just giving all the animals the same food. You wouldn't do that, even if it's a good food. You'd say, well, it's not going to please them all. So give a mixture. So I think we're going to see more of that, which is very hard for industry to do. But it may be that we can move towards, at least the 5 most important, or whatever it is, like that.
Do you think the results, I mean, they're pretty spectacular from your study. Do you think this is enough for like the traditional medical system to adopt, like, for example, like the Zoe test? Is this something? I mean, I would imagine if I go to my primary care physician or to my gastroenterologist, that would be the simplest way of assessing, do I have that microbial risk factor that contributes to whatever my other risks are for colon cancer, or do you think it will need significantly more evidence before the medical system will kind of incorporate this into the mainstream?
Well, it's been developed not as a medical device, but as a wellness device. And this is a trap of the legislation in the US, is that to avoid getting regulated by the FDA, and which effectively stops scientific progress, because you have to sort of lock it in at that point in time. And we would have locked it in 4 or 5 years ago and have a very crude test that we couldn't change easily at that point in time. So we're not allowed to do all the things that we'd love to do just because of these outdated regulations. Whereas, we'd love to, we've got a paper coming out, we're just submitting. We looked at 300,000 people. This is now the big Zoe data set now. So it took years to analyze this computationally. So to get to 34,000, now we've got 10 times the number. And we've just looked at all the diabetes patients in there, and we can predict with 85% accuracy who's got type 2 diabetes, and with 80% who's got pre-diabetes. So we don't need, it's as good as a glucose monitor. So there are all these potential uses medically, as well as you hinted, those cancer prediction ones, which, there's a rare bug in there that we can detect if we were allowed to, that it gives people tenfold the risk of colon cancer. And it's an early sign, it's an early pickup, because this microbe just goes in there and hangs around. But because of these regulations, we'd have to spin off another company to do that. So it would be good, though, to speak to regulators and say, well, how do we take this science and make it into something that the public can use and that can get reimbursed by practitioners, etc. So it moves away from being a sort of wellness tool to being a medical tool without us getting shut down as a company. So that's the sort of dilemma that we're facing at Zoe, is that, we do all this science, but we have to channel it into away from specific diagnoses, although we could diagnose a lot now. But it's only recently got good enough to do that. I think that's the measure. But you think all these screening tests we do, if this was adopted globally, you could get the price right down. And you think this is so much more valuable than just doing another lipid test. That you do every 6 months. You could give lifestyle advice, it'd be like an annual blood pressure check, I think. As you could start to include colon cancer testing in that, it could, reduce the need for colonoscopies and other things as well.
But when you think about it, what the medical system is willing to spend on the earlier and earlier colon cancer screening, which is not really a way that you get to pick it up really early. You would still see the lesion already that has developed. It wouldn't be prophylactic. So I think.
Whereas to send a stool sample, compared to the cost of a colonoscopy, it starts to make sense. So I think realistically, we should start. I'd love to see in 10 years' time this is a routine test that people get in that with their family physician, in the same way that we're wasting lots of money on blood tests just because they've been around for a long time and not really that helpful, but we do them just because they're traditional. But that's where I think it would be, and also tailoring our diet to this. So we are looking at ways of looking at the stool tests to potentially personalize prebiotics as well. So the next year we're going to be looking to see whether, because everyone's different, is there a different ratio of the fibers that would be particularly useful and get even more benefit from these things. So that could be the other way these tests could be used, as well as the diagnostic side, I think. And many more. We probably discussed it. How do you react to drugs? Is an antidepressant going to work for you? Is which pain-killing drugs are going to work? Which ones get deactivated? So I think as the science gets more robust across populations, and we've got this now stable platform, I think we can really start to exploit all the exciting elements.
So do you think, based on your knowledge, I mean, there's one other company, microbiome company I can think of, that had a similar model of having patients essentially, pay for the test, but also collect the data. I mean, do you think is Zoe right now the one that's the front runner in this development, or do you think there's other companies that are going to catch up with this as well, particularly with the numbers and the publication? I mean, that these numbers that you were mentioning, a sample of 300,000, that's kind of unheard of.
Well, there's another company in the US that claims to have bigger numbers, but they don't have the systematic recording of the health outcomes and the data, and they don't really publish in the same way at all. So we're very, very unusual in that we take a very systematic scientific approach to this, because we're very much science-led rather than marketing-led. And so it's a huge obstacle for someone to come up with this sort of database, and we hope to get it to 1 million people, within a couple of years. I don't think anyone else will be able to match that to the same level, and no one's doing the same metagenomics. So they have other companies doing their own metatranscriptomics and stuff like this that hasn't really been peer reviewed or followed by anyone else. So rather unknown element to it. So I think we're in a good position. We just need to start working out what the practical uses of this stuff are. But certainly people do find it really helpful to get a baseline of what their gut microbiome is, and then change their diet, look at it a year later, see they're moving in the right direction. Very motivational in terms of looking at these. Now we've got these clusters. We can look, for example, fermented foods. I'm always talking about how good they are. You can start getting your 3 to 5 portions of those, see if your immune cluster actually improves, as in those trials. Things like this are very exciting things we can start to do once we get people using it on a regular basis and following up, and then we can look at that follow-up data as well. And luckily, we've got lots of Zoe members who are about to do this.
No, this is really exciting. So coming back to this earlier question that I mentioned, that people have been asking. So we know today more about what a healthy gut microbiome is in the Western population. I mean, this may be different. For example, I often think about this, like, the traditional Inuit diet, for example, many fatty fish and very few plant-based products. But for the Western population, in the two major Western countries, we are able to say what a healthy microbiome is. Consists basically a predominance of the healthy microbes over the negative ones.
Yeah, no, exactly. So we haven't covered every population in the world. There are always going to be exceptions. But I think in comparable countries, whether you're male or female, regardless of race, different ages, we've now got a standardized way of looking at how good is your gut health that you can track over time. And however bad you are, you can always improve it. That's what our longitudinal studies also show. And yes, this is a really important starting point for the whole field. So, yeah, I'm very excited. This is, is going to give a real boost to the microbiome world, which has run a lot of criticism from the non specialists in other areas who always seen it, looked a bit jealous, but also critical.
Yeah.
So, saying, well, it's not real, it's all marketing. Don't believe these stuff, from those 50-page reports, which were a bit of fantasy, really, hopeful thinking. So hopefully we can get it really, it's nicely grounded now, and we can work on that and convince the rest of the world of the importance of
and I
gut
have to
health.
say, for my own personal interest or primary interest about the interactions, like the brain gut microbiome system. So you haven't really looked at populations with chronic brain disorders, but I would imagine that's another area. I mean, I'd love to see the results. Are there subsets of patients with depression, for example, that you can actually identify on their?
Yeah, well, psychiatry desperately needs some biomarkers, and this could be it. So I think we've got at least 10 to 20,000 people on medication for depression in our data set. So that's, again, on the list of things we're going to be looking at soon. So yeah, I think we can start to get these signals and really start to make inroads in these areas.
Okay, Tim, I think I've come to the end of our conversation. I don't need to ask you this question. How positive do you see the future in terms of counteracting the current chronic disease epidemic? So this is definitely a significant step forward in this area, and it will take time probably before this information reaches the majority of the consumers. It's still something, I would say, in the US, it's still a bi-coastal phenomenon that people are changing their diets and lifestyle but there's still a lot of people in the US, for example, that don't even know what a microbiome, have never heard the word microbiome. So I think a lot of work to do to move forward, but this is definitely a major milestone that.
Yeah. And people can get this test themselves, get it, should be available in the US in about February, I think, in a few weeks' time. And so I'd love people to try it and, talk about it and share it to your friends and get everybody interested in gut microbes,
Okay.
and share it to your physician as well. Because I think we need to also educate the medical fraternity as well about this, that, there are these things that are motivational for people in changing their habits and lifestyle. Yeah, it's hopefully 2026 is going to be hopefully a transformational year.
Okay, thanks, Tim. Great conversation. Very interesting topic.
Okay.
Hopefully talk to you soon again.
Yeah, speak to you soon, Emeran. Bye.
Okay, bye-bye.